All right, welcome everyone to yet another episode of the Boost Your Biology podcast. Today, I'm joined in with Pedro coming in from the US. He's a pretty close friend of mine. We've been exchanging messages over IG and bouncing ideas and discussing all things related to health and wellness. And yeah, I'm really looking forward to having a pretty in-depth discussion around, I guess, bacteria, biofilm, enteroviruses, toxins, hormesis, herbology, EMF, and all that good stuff. So, Pedro, welcome to the show.
Thanks for having me, Luke. It's a pleasure, man. I'm looking forward to all the stuff we're going to discuss too.
Wicked. So, maybe you want to start out by, I guess, giving my listeners a little bit of a summary into how you got into what you're doing today.
All right. So I've always been into health and fitness, and I started as a personal trainer. And throughout the years, I had a dog and a cat. The cat was relatively healthy, but my dog had Lyme disease. I didn't know what Lyme disease was at the time. And because of it, he developed cardiac issues, hypertrophic cardiomyopathy, where his heart enlarged and the walls got really thin. He got progressively worse as time went on. And it wasn't until a few months before he passed away that I realized he was positive for Lyme disease through IgM testing. So it was a very short run. I tried all I could. And unfortunately, I felt like I failed my dog. That left a strong enough impact on me to pursue something within the medical field and related fields to really understand the complexities of the human body, of life itself, so that something like that would never happen again. And that's how I got into the position I am now, studying biomedical medicine, biomedical research actually, and biotechnology as well. Undergrad,
Awesome. Yeah, interesting. So what about, for those who are unfamiliar with what your IG profile name is, Thucydides. Yeah, Thucydides. Do you want to just give that a little explanation onto that, who that is?
Thucydides was a Greek philosopher, and he had a very good quote that resonated strongly with me, which was a society without, or a society with warriors that do not think and thinkers that cannot fight is an incomplete society. You need to be both a warrior and a scholar. You need to fight for what you believe, but also be open to exploring what you don't know. And that makes at least as close as possible to a philosophy of life that I aspire to have as well. So being well-versed in the literature of science is important, but also embodying that through my day-to-day actions and what I'm looking to do in life is as important as knowing the books and the research and the topics that we, for example, are interested in. Because if you just spill things out on Instagram, we discuss what we have researched in terms of, for example, biohacking, nootropics, and all that stuff, but we don't really embody it and pursue something greater because of it, then I see it as a pursuit that doesn't have any worth, basically.
Yeah, that's fascinating. What about in the whole realm of, I guess, like biohacking and things like that? Is there a particular like interest of yours in that space currently, or you just
Actually, yeah. So a lot of people don't really know this because I don't speak about it, but I have some really bad ADD, man. And it comes up quite often when I'm doing schoolwork, for example, where I can't focus for more than 2 hours. So obviously, I've looked into many aspects of it. One of the most common sides of my pursuits with nootropics is understanding how we can manage the ADD and the symptoms that come with that. Something that really interested me since the beginning that I've talked to you about was adrafinil, modafinil, and that's something that's helped me out tremendously. Certain peptides like NuPep, for example, is really, really useful. So those are areas of nootropics that I'm really interested in. Although I have to say, I don't devote as much time to understanding how nootropics work and their biochemistry as, for example, with what you're doing. For example, I never knew that you can mimic the ketogenic diet and the GABA-induced brain effects without being on ketosis. This is something completely new to me that I've seen you post about.
yeah. I mean, that's I'm similar to you in that regard. I just like to not only research, but then also experiment as well. Because, you know, you can read one thing on a particular paper, but then when you try it and personally experience it, then you'll never truly know like how that compound's going to affect you. Like we all have that, you know, unique neurochemistry and unique makeup that I think a lot of people need to respect and build that
Individuality.
Yeah, exactly. So what about, we'll sort of segment into a little bit on, I guess, bacteria and biofilm for my listeners, because I'm sure many of them are unfamiliar with what they are and things like that. So do you want to talk a little bit about that?
So the best way I could simplify this is a biofilm is an aggregate of bacteria, parasites, fungi, viruses. It all depends on certain biofilms, the location of where it's growing. You could think of it as basically the pond scum that just sits up right by where the pond hits the soil and it's really thick. The same biofilm formation occurs in our intestines, occurs in catheters that are given to patients. It occurs pretty much everywhere. Biofilm is actually the natural state of microbes. They want to stay in a group together as if they're all hanging out inside of a bar. And when we have biofilms, the nucleic components, the DNA, the RNAs, they get exchanged between the microbes. It doesn't matter if it's a parasite, a gram-positive, gram-negative bacteria, they all become exchanged to some extent. Some are either inhibited, some are enhanced. It depends on, once again, the biofilm colonies. But many people don't realize that when we have biofilms in our intestines and we have symptoms of it coming up, for example, as brain fog or some kind of other condition neurologically, it can be addressed by disrupting the biofilm and then killing the pathogens with antimicrobials. That's the best way I can explain what a biofilm is, but it goes a lot deeper into it. And for example, the sense that biofilms are actually very interesting in that they align with Earth's magnetic field. They have biomagnetic, or ferromagnetic is the right word, components that allow them to align with the magnetic flux of Earth. By simply altering the magnetic flux, you can disrupt an entire biofilm. That is something that's so fascinating to me.
And so this like disrupting that magnetic flux, is that sort of linked into, I guess, like EMFs in any way? Or
Yeah, so this is one reason why EMFs make mold so difficult to deal with, but also exacerbate their mycotoxin release. So mycotoxins are the weapons that mold have to disrupt and kill any other pathogens. This is why the antibiotic penicillin works pretty well, because it uses mycotoxins to kill the bacteria. When we have EMFs, it seems as though the EMFs trigger some kind of genetic response from the pathogens, from the mold, that cause them to release excess mycotoxins. When that happens, we usually blame EMF, but it's possible and probably a very strong possibility that it's not that the EMF is threatening the mold into producing more toxins. More so, it's orienting its genetic components into producing more toxins. It's an epigenetic effect, basically. And I think that happens with every organism on this planet, because every organism is affected by the magnetic fields of Earth. And when I say magnetic flux, it just means the Earth surface area from which the magnetic field comes out. So if you look at, for example, where you're located in Australia, if you just outline your city and you explain the magnetic field that comes out of it, that's a flux.
right, interesting. So I guess maybe for a lot of people that either are suffering from some sort of chronic disease and things like that, how does, I guess, like mold exposure influence somebody's like wellness and vitality?
Right. So mold by itself, every single mold or myco species is in some aspect pathogenic, because they all elicit effects in our body. Some of them, like the Stachybotrys, which is the water building mold that grows from water damage, those can be very, very destructive to our nervous system, to our brain. They literally induce apoptosis in cells by caspase enzymes in the mitochondria. So they kill the mitochondria, so the mitochondria then release enzymes that kill our cells. So just by the nature of mold itself, it can disrupt pretty much all bacterial life, including the mitochondria. By doing this, it disrupts our functions neurologically, especially because our brain is so mitochondrial dense. It can cause cardiac issues like POTS, because our hearts are also very mitochondrial dense. It can cause problems with our guts, and increases histamine release because it exacerbates our immune response. So I think different molds have different responses based on bioindividuality, but also we can probably rule a certain number of mold in specific conditions. For example, aflatoxins causing liver cancer, and that's pretty well known, established in the literature too.
So I guess then, do you think it's possible that, you know, we can build up a strong enough immune system and sort of vitality to then sort of offset the damaging effects of mold? Or do you think that like it's probably more beneficial that we remove the source? Because obviously it's a bit difficult for some people after exposure. Are there things that they can do?
I think if we were to have built our immune system to respond to mold, it would have been done long before, because we were encompassed by all these different fungi species and we're still affected by them in modern times. Something that's interesting to me that I realize with mold patients and clients that I've worked with and people that I've known that are affected by mold is they usually have the genetic susceptibilities, but it isn't turned on until they come into exposure with some kind of mold damage from buildings. So I don't think the immune response is something we want to focus on as much as getting away from the sources and seeing if we can address the genetic response that we get from mold by addressing something else like our gut microbiome, because we know that the same biofilm community can be good for us because they exchange genetic components with us, and some of their genetic components are actually resistant to some of the mycotoxins, like the bacteria Klebsiella. I'm sure you've heard of it, right? It's resistant to a lot of the mold toxins. So when people get exposed to mold, what happens is Klebsiella overgrows in their intestines and then autoimmune conditions develop. Really, it's just that Klebsiella is the lone bacteria now that is able to overgrow because it can be defended against the mold toxins.
So this Klebsiella bacteria, I don't know if you've heard about it in the context of ankylosing spondylitis and those sort of conditions. But what else is that sort of linked to?
Well, there's a lot of autoimmune conditions that can arise from Klebsiella, but I don't think I can say that it is the lone pathogen that causes multiple autoimmune conditions. I think that it affects certain people, and depending on, once again, their bioindividuality, it may manifest as something in specific, whether it's pulmonary conditions or something more systemic like lupus.
Okay, so what about yeah, because I know a lot of my listeners are either suffering from like an autoimmune condition. So in terms of like what's actually happening in the body in those autoimmune states, like, do you want to explain a little bit about what autoimmune disease actually is?
So in my opinion, and this is my opinion alone, I would love to say that autoimmune conditions are just your immune cells attacking your own body, but I do not believe that's the case. If this was the case, when we had such a strong, thriving immune system, years before these were conditions that were being recorded in history, it would have happened before more often, in my opinion. I think that autoimmune conditions are by far two things happening. One, metabolic dysregulation, where you have more metabolic waste from our cells being built up within a certain localized area, and that can develop as something like eczema. For example, when we have too much retinoic acid, it literally burns pores in our skin that become eczema. Or it could be something like a stealth pathogen, which I have to dedicate most of this information to a friend of mine, Dr. Jess, where pathogens themselves become implicated in the autoimmune disease, but they can't be diagnosed. We're looking for serological tests when they are more in the lymphatic system. And usually they will stay dormant just enough that the immune system doesn't produce antibodies that can be detected through testing. When that's the case, then it becomes very difficult to diagnose somebody with a proper reason for why an autoimmune condition develops. One example of this that's really good is in multiple sclerosis, where retrovirus transponsons elements, basically the compounds in our own cells that produce viruses, our own retroviruses, become activated. And it's very difficult to diagnose this, but it can be tested with some aspects in specific testing, where we see that multiple sclerotic patients have these active retroviruses, and others that do not have the multiple sclerosis don't have them as well. It's like a clear indication that there is a pathogen in response to the disease, but we can't say if that is the reason why the disease developed in the first place. There's connections, but no causation that we can say for sure.
Right. Yeah, interesting. So what about you? You obviously mentioned a little bit on like the lymphatic system, and I know that we've had a bit of a discussion about like some specific herbs and things like that to enhance and improve that lymphatic system. But do you want to discuss a little bit about the lymphatic system itself?
Yeah, so to simplify the lymphatic system, it is basically the one system of our body that does not have a pump to regulate its motion. We would, for it to move the fluids, we need to move ourselves. And it is a sewer system of our body. If we never took care of the sewer system, we had a faulty sewer system in our house, toilets would overflow, back up, and then we have pretty much shit all over our bathroom. And then sooner or later, it's going to wind up to really unhygienic conditions that cause proliferation of bacteria that can cause disease. So the same sort of thinking can be applied within our bodies by properly helping our lymphatic system, our own sewer system. We don't have those metabolic wastes clogging us up, the endotoxemia clogging us up, the pathogens and their own byproducts clogging us up. What will happen is all of it gets flushed out in a perfect world through our emunctory organs, the kidneys being flushed out through urine, the intestines being pooped out, and the skin expelling it out, and also our lungs, which also expel it out in a sense. And what we would have is a perfectly clean lymphatic system. Being that the lymph nodes themselves are where most of the maturation of immune cells occur, if we don't have proper lymphatic flow and fluid viscosity is really thick, then pressure increases. If pressure increases, we're not going to have the cells that need to be mature. And this is the condition that arises in a lot of metabolic conditions or syndromes, such as obesity and diabetes, where these people don't have a robust enough immune response to certain diseases and they become immune compromised. This can be traced directly back to improper flow of fluids within the lymphatic system.
Yeah, interesting. So in terms of a like a bit of a protocol to, I guess, support the lymphatic system. I know that a lot of people are engaging or undergoing the carnivore diet. And so if we look at that diet, we obviously can see that it's lacking, you know, the polyphenols and a lot of the things that we find in herbs that actually stimulate the lymphatic system. So it sort of makes me wonder, do those on a carnivore diet actually have compromised lymphatic systems? Like, what are your thoughts there?
So I do know that as we break down a lot of the fatty foods that we eat and focusing mainly on a carnivore diet, it's a lot of fatty foods, a lot of fatty red meat. We package them into myceles to be taken up by the lymphatic system. That's where fat goes, whereas protein and glucose go through our circulatory system. What's interesting about these fat molecules are that they are polarized, so they repel each other. And this is also found in our circulatory system. Our cells repel each other because if they didn't, they would coagulate and then we produce clots. This is what happens with inflammation. So a high fat meal by itself may actually be effective at improving lymphatic flow because you have this polarization of molecule pushing each other away. So everything moves steadily through the fluid, which is our lymphatic ducts in the fluid, just fine. It may be that as you do just a carnivore diet by itself, you're actually improving the flow of your lymphatic ducts based on polarization of fatty acid molecules. But at the same time, if you don't have enough water to help repel the fatty acid molecules, which can develop with a lack of electrolytes that's present in the mitochondrial diet, the carnivore diet, you don't have enough potassium coming in, you don't have enough sodium at times, depending on how much salt you have. So the water retention is very low. And in that case, the lymphatic system can become, for lack of a better word, clumped up. And from there, you're going to have problems with lymph flow throughout the system. That could be a reason why, for example, lipoproteins that need to be delivered to the specific areas are not getting to where they need to go. And then atherosclerosis forms, or plaque formation, basically.
Right. So what about, let's have a little chat about the implications of a carnivore diet on the microbiome. I know Paul Saladino has spoken very briefly on it, but I'd love to get your thoughts on like how that sort of diet's going to impact the microbiome.
I definitely think when we eat certain foods, we affect which microbes become the dominant ones. So if we eat specifically a lot of sugar, We know that yeast tend to overgrow, and we don't know for sure if that's really good or bad. It's such a complex topic. I know you know Ray Pete. He always recommends eating high sugar foods, fructose, and everything. And to some extent, he has some really good evidence behind it. But at the same time, it's clear that some people get affected by the fungus from eating too much sugar, so they need to cut it out of their life. And that's usually what causes people to go into the elimination diets, like the carnivore diet. And the fungus or the microbes that cause a disease or the condition that they're feeling, whether it's bloating or something as serious as Crohn's, they don't have the fuel source, which is the fermented vegetables, the FODMAP food, basically, to produce their metabolites, and they die off. The thing is, I don't think they fully die off in the long run unless you do it for an extended period of time, like years. So by changing the microbiome in the short term, you get relief. But then when you reintroduce foods, you have the symptoms flare up again. However, for somebody like Paul Saladino, who's been doing it for years, this may not be the case. His microbiome may have switched completely into the putrefactive bacteria that digest proteins well, and then that break down fatty acids well. And in that case, it may benefit him because he has lower lipid peroxidation in his gut, so his gut is less inflamed, and he also doesn't have the microbes that cause the inflammatory cascade. It's a very complex issue in that most people with mutations like MTHFR will do really well on the carnivore diet, but then people that have ApoE mutations will do horrible. In fact, it'll raise their risk for heart disease substantially. It's very complex. I can't say that it's bad or good, but it does have short-term and long-term effects on the microbiome. Whether it's good or bad depends once again on the person.
Yeah, that's well said. So what about your personal experience with I know you personally experimented with it, but now you're sort of leaning slightly away from it. So do you want to share your experience?
So I did decide to go on a carnivore diet twice. So the first time I did it for 3 days, I did not feel good. I had really sweaty hands, and what it seemed like to me was a sign of hyperthyroidism, which is something I struggled with before, actually.
Wow.
But the second time around, I did it for a period of about 3 weeks. I have to say the first 2 days, there's an obvious adjustment period. Your body almost feels as if it's lacking energy despite you consuming a large amount of calories coming from fats, which it makes sense because one, fats are slower to oxidize through beta oxidation than glucose, but also because your body is switching substrate fuels over the long run. After about a week, I felt a sense of calm, which can be attributed to, like what you said, low serotonin and higher GABA neurotransmitter activity, which is the case also with ketosis. And then at about week 2.5 to 3 weeks, I started craving carbohydrates really bad again. And I started to ask myself, why is this? I was getting all of the necessary minerals, all of the nutrients I needed, but I still wanted carbohydrates. When I first reintroduced them, I had obvious gut dysbiosis, bloating, and it affected me because I did it for only a period of 3 weeks. But had I done it more in terms of duration, maybe I wouldn't have had these effects. However, after I introduced carbs again, there were clear distinctions in, for example, my executive function. When I was in a carnivore diet, I couldn't focus for a long period of time on learning things. Whereas when I consume a large amount of glucose and carbs, that allows me to learn more effectively in a short amount of time. But the downside of that is I also don't feel more clarity, more aware of my day when I'm eating glucose at high enough amounts. But when I was on a carnivore diet, I felt this immense clarity. Everything just seemed extremely HD, for lack of better explanation, basically. That's one thing I really enjoyed about the carnivore diet. But at the same time, I just don't think it's something that for me would be a long-term solution for the things that I'm dealing with, for example.
What about the impact on your like physical training and things like that?
Yeah, so it didn't reduce my strength. It didn't reduce my markers of activity. It actually enhanced them. And it makes sense because obviously when you use the beta oxidation, you produce about 5 times more ATP per molecule of fat than you do if you were using glucose. So energy expenditure was obviously higher. The lack of inflammation was present as well because the beta oxidation actually produces not free radical O2, but just normal oxygen that's higher in stability to help reduce inflammation. So when you have too much CO2, you produce more lactic acid and inflammation rises. There was a clear distinction with that, but it also wasn't something that I felt my best with. I didn't feel the drive to work out. I think that the neurotransmitter activity that was occurring on the diet had actually made me more docile, very relaxed, like I didn't want to work out. It's interesting.
Yeah, definitely, definitely. So we're going to sort of segue into a little bit on, I guess, herbology, because I know that's an area of interest for you, and same for me as well. Like I love to research and dive deep on herbs and understand them from a very like biochemistry point of view, things like that. So do you want to sort of like share your sort of areas of interest around herbology?
Yeah, so I definitely think what we know about herbs and their mechanisms and how effective they can be for certain conditions is so large. We're just not looking in the right places. A lot of scientific literature is present to show these compounds are exceptional aids to a lot of conditions. A good one, for example, a good example of this, actually, not just a herb itself, but chemotherapy, which is used for cancer, is derived from alkaloids of plants. I mean, that's one of the most lucrative businesses for cancer. And people often forget that it's from plants that these compounds come from that are anti-carcinogenic. So it's the same with eating the foods. It's just that we don't have the higher concentration of alkaloids, phyto compounds, phenolic compounds, flavonoids that induce the same effect in the high concentrated single chemical compounds in chemotherapy, for example. I think we're literally sitting under a gold mine of information that's just not being expressed and shown to people in day-to-day life. And I know, for example, dealing with neurochemistry, just by taking in certain herbs, you can improve your brain chemistry so much. You can reduce tau aggregates, improving your resistance to getting Alzheimer's disease in the future. It's a lot of information that's just sitting there.
Mm, absolutely. What about I know that we've both sort of bounced ideas around like using adaptogens. So I'm curious to know like your experience with a lot of the popular and famous adaptogenic herbs.
So I can tell you that the reason why I like adaptogens is mainly because I know I'm prone to being easily stressed out, especially when I have so much going on at once with school, for example. So I would go for something as simple as ashwagandha. But then I know, for example, for other people that are prone to being high in serotonin, for example, they do worse with ashwagandha. And it makes them have even more symptoms of anxiety and depression. So it really does differ between person to person, but adaptogens are such a useful tool for people that get really stressed out easily, like myself. I have a low stress tolerance that have very little amount of sleep. They help improve the energy production just enough to get you through the day. And also for mental acuity, when I take adaptogens like rhodiola rosea, I have an obvious improvements in my mental acuity.
Mm. And you also had experience with Shilajit as well. It's something,
Yeah.
yeah.
And Shilajit to me is more of a food. It's just a food we consume in small amounts. And we consider a supplement because of the packaging, maybe the pills or the resin itself. But it is a food. It's biomass. It's minerals. It's the same thing we'll get in a plant, just in a very condensed fashion. And basically, I guess you can say it's just preserved for a longer period of time. And in this case, 50,000, 100,000 years.
Yeah, I mean, when I first started using Shilajit, I remember actually it was like a Monday heading to uni, and I remember like when I first had the resin, I actually experienced like a very strong vibrational,
Yeah.
like a particular vibrational rush. I was like
Interesting.
a full body like vibration. It was really like powerful, and I remember walking to.
How much did you take by any chance? Do you remember?
I had like a pea size, like a
Yeah. 20 milligrams, probably. Yeah.
tiny amount. And yeah, I remember experiencing like getting that vibrational rush and feeling really like calm and focused and grounded when I got to uni. I haven't been able to replicate that effect. I know it's like probably initial like adjustment period where it's probably like I don't know detoxifying or changing the vibrations, things like that.
I do think that Fila G has only made me feel that way when I haven't taken it for a long period of time and then I restart again, or when I know that I don't get enough rest, for example. It just gives me that little edge, and I can feel that. The vibrations that you may be feeling internally here, you know, I don't want to dismiss, as much as the scientific mind that I have, I always want to be encompassing all the spiritual aspects of things. Shila Ji is one that, at least in the Ayurvedic tradition, is used to improve the solar plexus chakra. And that has to do with going out into the world, and inducing effects, seeing what you want to create, giving content away, helping people. So it does have, in some instance, a spiritual effect on our psyche and our emotions and the actions we take. That's why the name Destroyer of Weakness, Conqueror of Mountains is what is coined Shila Ji. It has that interesting factor of not only physically improving your well-being, but also mentally.
Mm. Yeah, and it's a real shame that a lot of the scientific studies, like, that's going to be impossible to measure. Like, it's virtually impossible to measure that aspect that we're talking about now.
Like the emotional content of it.
Yeah, I mean, like, it's difficult. I know it's like being studied heavily in the context of like enhancing ATP and mitochondrial efficiency, things like that. But
You know, there are scientists actually. I do not remember what is the technology that they used. I only saw this one time. There are scientists that are using specific measuring devices that they can actually plot on a graph and see in terms of, for example, thermal frequencies in the apps that they use. I don't know what the device is, but they put electrodes on a yogi that's doing meditation to measure different points of chakras. For example, the throat chakra, the eye chakra, and they see the thermal frequency of the emission that they get from the electrode when they say they're going to activate a specific chakra. And what happens is that say the electrode is located in your third eye, the thermal frequency of it rises, and they can actually plot this on a graph over a period of time. And it's amazing. By willpower alone, they can change the reading response from the electrode into the graph, which, at least to me, tells me there's some sort of measurement there. It's just that we don't have the right measure of association to what a chakra is. What is that energy? Is it electromagnetism? Is it thermal? We don't know. It's tough to say, but it's there.
that's really cool. That's actually, yeah, that's cool. So what about, I guess, we'll sort of segue a little bit into light exposure, because we haven't really had a chance to talk about light. So do you want to, like, yeah, is there an area within that space that you'd love to research?
Man, I think light is the basis behind it all. So let me start by saying, with chemistry, we love to look at the compounds and how they have specific effects, how NuPep increases neurogenesis, or whatever the compound may be. But all of it is underlied by electrical action. Every compound has an electrical component to it, and at the atomic level, that elicits the effects we're looking for. And every single time we can confirm that effect. For example, you know that if you take a statin, it's going to reduce cholesterol. Why is that? Why can we trust that this drug will always reduce cholesterol? Why do we do randomized controlled trials to measure this every single time? The fact that it all comes down to electrostatic interactions between molecules, it's amazing to me. What underlies electrostatics is electromagnetism, and light is carried through an electromagnetic wave. Every day we wake up and we don't say thanks to that thing up in the sky, that sun that produces the electromagnetic waves for us every single day, that works in a chronological fashion and an optical fashion. The chronogenetic response that we get from a sun, meaning the timing, circadian cycles, is amazing. The optogenetic response is also something we don't take for the value that it provides. For example, researchers at MIT, biomedical engineers, were looking at how they can measure epigenetic responses. So they found that when they induce specific light waves of higher frequencies, which means that the wavelength is shorter, so it's very, very, very fast. Blue light, for example, they could induce histone decetylation and gene expression way easier, just by light, better than any drug that they've used before. And when they use lower frequency waves like radio waves, it didn't have the same effect. That's one example. The other example is, for example, the expressions of genes can be inhibited by light as well. It's called tumor-like activator effectors, TALE. and I'll send it over to you right after. But they are responding to light patterns as well. Crypto, man, these names are always me, but it's a specific protein that is responding to light that allows these transcription activators to either allow the gene to be expressed or not. Certain light can inhibit this, and then the genes don't get expressed. And then certain light actually enhance this, so the genes get expressed. This one area of research is actually very well explored in plants, where they see that if you don't have the specific gene that allows blue light to help the plant grow, the plant will have deformities. It will have what is the right word? It will be very mutated. The mutations are very apparent in the plant. The same thing can happen in the human beings. We don't get light for a certain period of time. We don't have the specific genes that are expressing in a chronological fashion and in optical fashion. That will sooner or later express itself as either disease or some manifestation of disease. I hope I was able to break that down as simply as possible, but what I'm trying to say, even simpler, is that light and circadian cycles dictate everything about our cells and our genetics, basically.
With that blue light, you mentioned if the plants lacked that blue light.
Yeah, so I'm trying to remember what it was called. Crypto something. Cryptochrome. So bacteria, they're chromophores. They respond to light. Plants use light for photosynthesis. So cryptochrome proteins are what absorb the light from the UV and allow the expression of certain genes. For example, the blue light from the sun allows the plants to grow a specific way. And if you don't have that blue light, the plants are deformed, they're mutated. We have those cryptochrome proteins in our own body. And the response we get from light allows our genes to express by the transcription-like activator effectors. And this is all mediated by light. So if you don't get enough light, those genes are not expressed, or they are expressed in ways that shouldn't happen. That's underlying all of the basic chemistries that happen in our body we take for granted because of light. The area of research for this is optogenetics.
Optogenetics, cool. We'll be linking those in the show notes for those listeners. It's definitely a fascinating area. There was one thing you mentioned about the histone D HDAC. Yeah, and you said that certain lights can actually activate that process, and that's
So usually it's higher frequency light. With higher frequency, you have higher energy. So when you, for example, turn on infrared light, to some extent, you can see some of it, and that's actually low. That's actually high frequency. So you feel that amber light coming from it. That's heat. That's because the kinetic energy of the light produces the heat. Whereas lower frequency, you don't feel as much, and that can be something like radio frequency, where the wavelength is so long that it just penetrates everything, but we don't feel the effects from it. So these higher frequency energy carrying lights have this effect on the responses that we have in our cells and our genes. This is partly due to ionization. Obviously, when you ionize something, you're going to get an increase in kinetic energy, and that's why that can happen.
So then what about artificial blue light? So how does that?
So as you can already imagine, non-native EMF, electromagnetic frequencies, that even though they may not be ionizing, they're still carrying high energy, will have some effect on those proteins. One interesting thing that can happen is you reduce the black body radiation, basically how much radiation you yourself expose into the day, into your world. Everybody to some extent exposes radiation. The more radiation you can absorb and expose means you have a higher energy like a baseline. We see that with people that are sick, their radiation exposure skyrockets. And that's why you can use a thermal gun, for example, to see how much their body temperature changes. When people are overweight, we see a lack of radiation exposure. And that's an example of low temperature, which is what we call hypothyroidism. An effective hypothyroidism is we get a lower temperature. That can be the same, it can be translated to physics as a lack of kinetic energy, where you're lacking electrons. You're lacking the main substrate in the mitochondrial electron transport chain for everything to operate. So non-native EMF as blue light can have a substantial effect on all of our physiology just by this interaction of light, chemistry, and electrodynamics alone.
It's crazy. It's just really emphasizes the importance of making sure you filter out that blue light, that artificial.
Right, like blocking glass. The problem is, it's not just the glasses that we need to be focusing on. Our skins are exactly. We have histidine. Histidine captures the light and it transforms it into whatever biochemical response we need. Whether it raises histamine, for example, with the carboxylation, and then we have a histamine response that is not suited or we don't want, and our immune system is overactive, and then we have, for example, problems with our gut because we have too much histamine response. We don't relate it to non-native EMF. We relate it to the foods that we're eating. When in reality, it's just because we're being bathed in this high frequency energy environment.
Mm. So what about I mean, I personally have experimented with like sun gazing. I mean, I tried it probably about a year ago, and my initial response from like undergoing sun gazing was I noticed a particular reduction in appetite. Like it was actually very noticeable. Like I could easily function with less food. I also felt like a bit more energized, or there was again a similar vibration to the Shilajit. So what's your experience been like with like sun gazing?
Same thing. What you're describing exactly the same thing I've experienced, and what I always experience when I don't get enough sunlight, and then I finally expose myself. I believe that the reason why, let's start first with the appetite reduction. Sunlight regulates leptin. Leptin regulates our appetite, and therefore, just by exposing yourself to more sunlight, your appetite diminishes. Also, by regulating leptin, you improve your insulin response, thereby increasing insulin sensitivity. You improve all metabolic markers. The second, the improved well-being, whether it is through awareness or clarity, being able to socialize with people, I think that has a lot to do with the fact that our eyes, when we receive sunlight, transmit through specific parts of our brain to produce more dopamine. And then with that rush of dopamine plus the endorphins produced by the sun, we have an exponential improvement in well-being, and at least your feelings of well-being.
Mm, yeah, and what about like I guess the influence that's going to have on the how somebody sleeps that night? Because then obviously it's going to be synchronizing that melatonin secretion, things like that as well.
So we know that actually melatonin, I don't know, at least to some extent, it may be that most people think melatonin is made at night and it's made to help us sleep. The reality is most of your melatonin is made as soon as you wake up with the sun and when the sun hits your eye. So this molecule is made from tryptophan, which is an amino acid that captures light. The light allows it to undergo its chemical reactions to become melatonin. And it happens the moment we expose ourselves to sunlight. When we don't expose ourselves to sunlight and we expose ourselves to non-native EMF, what winds up happening is we have a lower melatonin secretion. And from there, obviously, because melatonin is so useful for so many different conditions, I mean, it's being studied as a therapeutic agent for cancer. Just by itself, we have a lot of concerns as downstream mechanisms, whether it's appetite increases or sleep problems or obesity over the long run. So the main thing I can consolidate this to is you need to get sunlight to produce melatonin.
Yeah. So the other day I spoke about zeolite as a potential means to, I guess, enhance detoxification. So I'm curious to know your stance on zeolite and I guess maybe this is historical use as well.
I don't really know much about the historical use of zeolite. I do know that just as zeolite has been used by ancient tribes and specific locations in the world where these cultures have used them for detoxification in their own regard, so have they done the same for bentonite clay, where the same thing for detoxification purposes or skin health, all of that. I think that these binders, the main reason that they work is that they have a structure that allows positively charged, for example, molecules such as heavy metals to be bound and strongly bound through covalent bonding into the structure and then excreted out the body. So it works really well for things like heavy metals, and that's why zeolite is used in this case. I definitely think though that it's not a perfect binder, because where it lacks in some areas, some other binders can make up for it, like apopectin, citrus pectin, and activated charcoal. With, for example, EMTs, when somebody has a cocaine overdose, the first thing that they'll give them, if there's nothing else that they can do, is activated charcoal, and it pulls the cocaine right out so that they're not experiencing a toxicity that could kill them.
Right. So one thing that you reminded me of was actually a longevity supplement that I know a lot of people have experimented with, and that is C60.
Carbon 60, I forgot the guy's name, Buckminster Fuller's carbon 60 molecule. Yeah.
Yeah,
What
yeah.
about it?
Well, I'm seeing more and more rat studies. There was one famous rat study where it literally extended lifespan.
90% or so, right?
Ridiculous, yeah. And now I'm seeing more and more research. So seems like it's definitely an up and coming supplement, I guess, for just ramping up the body's antioxidant defenses. But have you personally experimented with it at all?
I have it in the sense of Shilajit, because I know that Shilajit contains a substantial amount of it. I don't think that just supplementing C60 by itself is a smart idea, because we know that carbon is what we're mainly composed of. We are carbon-based beings. Carbon itself interacts in interesting ways, especially with other molecules. It's never something that is intuitive. It's usually counterintuitive how it operates. I think most of C60's effect, yes, it has incredible antioxidant properties, but it may be in relation to other compounds and nutrients, elements that have synergistic effects in reducing inflammation, improving longevity over the long term. What's interesting about the structure of carbon 60 is how perfect in terms of symmetry, point symmetry, that it basically is one of the most stable structures that you can find in biology. Where you have stability in biology, you have good function. When a cell loses the stability through its membrane, it loses its function. And every level, as Ray Peat, for example, says, where you have good stability, you have good energetic components of whether it's physiology, biochemistry, everything. Stability underlies all of biology.
Which would make sense why he really pushes for the anti-puffer diet, obviously.
Oxidation and all that stuff. I think to an extent, Ray Peat is not so much anti-PUFA as he is reducing your intake, because you're already accumulating so much over a long period of time.
Yeah. Did you ever undertake like the anti-puffer diet at all? Like, did you try and eliminate them as much as you could, or?
No, honestly, I'm not so worried about the PUFAs. I think what matters more is for example, increasing vitamin E levels is an obvious. We don't have enough of that. Switching to seed oils, even if it's olive oil. Olive oil is rich in PUFAs. Every food, to some extent, has polyunsaturated fatty acids. Just what is the ratio of it compared to mono to saturated fatty acids? I think also the gut health plays a major role in this, because if we have certain microbes that increase lipid peroxidation, it doesn't matter if it's polyunsaturated or saturated. At some point, it will oxidize and then cause damage to our intestinal line. So I don't worry so much about it as much as where is it coming from? What is the source? If it's soy PUFAs, I definitely don't want that. If it's olive oil PUFA, I'm not as worried.
Yeah. And he also sort of explores a little bit about iron being very detrimental to health. But I'm just going to put my personal experience out there. I was undergoing so many strategies to lower my iron. I was donating blood every 12 weeks, taking curcumin high dose, taking vitamin B1 and other compounds that were actually lowering my iron. I eventually reached the point where I was basically anemic.
Right.
Yeah. Yeah. So, but then what really brought me back was not just eating red meat. I actually had to supplement iron. And personally, that was like the best thing I ever did, because then my energy just came back like threefold. But I guess he's definitely right in the sense that it is a very reactive metal in the body. I think it's second to mercury, potentially.
Yeah.
I
Go ahead.
was just about to say, I think under certain circumstances, it can be very beneficial, like iron supplementation. But I can see where he's coming from in the fact that, like, in particular men, they can't excrete the iron, so it accumulates and builds up in tissues. But yeah,
like hemochromatosis or something. It's interesting.
yeah,
Yeah, the fact that women have their menstrual cycles, they have an advantage is that obviously you lose blood, you lose iron. I also think that if iron was such a major concern, we would not have been where we are now, because most of our foods were high in iron before the agricultural revolution, hundreds of thousands of years of this anthropological period where we're consuming high iron foods. What came with the high iron foods was the other ratios of minerals that are counter or the antagonists of iron: copper, and in some instances molybdenum, uh, calcium. All of these have different interactions that we don't necessarily understand, for at least all of them, and how they interact with each other in one instance, but they're still present in the right ratios in food that's properly grown. I think if nature provides them in a specific ratio, it's for a reason. And it has to be a reason based on geography too, because certain foods that are found in the Arctic will not be in the tropics, and vice versa. There's reasons for that. And then certain foods there are higher in nutrients that might be absent in the other geographies. So focusing on one mineral, I don't think is the right approach. But I do think, because of the way we live now, we're evolutionary beings, where every single year is another breakthrough in some kind of scientific perspective. We're not yet accustomed biologically to deal with all of this. And so fortification of iron in our cereals, that's not the right thing to do. Consuming more red meat and not consuming foods high in copper like certain vegetables, that's not the right thing to do. Vice versa. So I think iron is, once again, by reducing it to that one component without exploring all of the possibilities of why it got to the state that it's in, I don't think it's the right way to go about addressing it.
absolutely. What about, we didn't really get a chance to explore a little bit of toxins, atrazine and other hidden toxins, things like that. So I know you're pretty passionate in that realm. So do you want to talk a little bit about how they can really impact our biochemistry?
Yeah, so a researcher out of California, Tyrone Hayes, that's his name, he studied atrazine in frogs, and he found that its endocrine disruptor capabilities were very, very high. And because of this, it caused the frogs to basically become emasculated and become feminine, to the point that they grew what it seemed like to be feminine organs. The amount that he used is obviously something that a human being would not get, because obviously the experiment was on an animal. But we know that even at the lowest parts per billion, these compounds have some kind of effect. Whether it's a nanogram range, microgram, doesn't matter. They will always elicit an effect. I think in combination with glyphosate, in combination with other pharmaceuticals that are in our water supply, in combination with the toxins that are inside of our food system, we cannot focus on that one toxin in parts per billion. We have to encompass the entire system, because we don't know if these toxins are synergistic. We haven't studied the synergistic toxicology of all of these compounds all at once. If one of them can elicit an endocrine disruptor effect, what happens with 1,000 of them? And when we have 1,000 of them in a parts per billion range, all of a sudden it shifts to parts per million range. And we do that over and over, day after day after day. Our system is not yet ready to deal with the substantial amount of different toxins that have to undergo some kind of detoxification in our liver, whether it's sulfuration, glucuronidation, methylation, doesn't matter. Every one of them has a different pathway. One pathway is compromised in the liver, you're going to have about a 17% reduction in overall detoxification capability. Over time, what will happen? If you intake more atrazine than you can excrete, it'll start becoming sequestered in fat tissue, and then it's going to elicit endocrine disrupting effect, and all of a sudden you're gynecomastic, you got man boobs.
Yeah.
So it's a big deal to me, without a doubt.
Yeah, for sure. Well, Pedro, we're actually getting close to the end. I want to make sure that this IGTV gets saved. So before we wrap up, man, do you want to just let people know how they can either work with you, go to your website, whatever you have, just let them know here.
Yeah, so I'm building a website. Once I have that out, I'll definitely give a link to where it can be found. you can just go on my Instagram, send a DM, and contact me or whatever. You can send me an email. Go to my link in bio. I have my email link in there as well. And once again, my Instagram handle is Thucydides, THUCYDIDES with 2 underscores, and that's it.
Wicked, man. Well, thanks so much for coming on the show, and yeah, look forward to yeah. Thanks so much. We'll speak soon.
Sounds good, man. Take care.
Thanks. Thank you everyone for joining in to today's episode. For in-depth show notes and lessons learned, visit nofilter.media/boost your biology.
This has been a No Filter Media production.
Say what you want.